Good morning, YouTubers. It's snowing outside. Actually, it's not snowing right now, but we're a little bit socked in for Portland. Portland is kind of tender around snow. We don't get it as often as, say, in the Midwest. So when it snows here, people kind of freak out, clear out the shelves. Supermarkets were kind of like raided last night, and we had like just a little bit of snow. But, that's what we're like here. We kind of overreact around snow. So what I am showing on the screen here is a video I just recently completed where we were connecting, or I was connecting the Bucky stuff and the Wittgenstein stuff and suggesting there were philosophical things we could say after making this connection. The connection was kind of a duck rabbit perceptual kind of thing because we're looking at this cube and we're seeing how, oh yeah, that's the volume 3 cube. No, wait a minute, that's second root of 2 to the third power. In XYZ, that's what it would be volume-wise, whereas in synergetics, it's the canonical volume 3 cube. And the way you go back and forth is perceptually, you just need to revise how you think about second and third powering. Is that a square and a cube respectively, or maybe a triangle and a tetrahedron? If you go with the latter, then you get into this a different paradigm, I would call it. And I don't mean to overhype the term paradigm. It basically means a grammar. In the Wittgensteinian sense, the rules change. So in what way do the rules change, and what can we talk about with quadrays here? Well, I want to talk about linear independence a little bit. What we would say in the XYZ linear algebra, which extends to any number of mutually orthogonal axes and dimensional Euclideanism, would say that one of these four basis vectors here has got to be linearly dependent, not independent. Because clearly I can take any three of these vectors, add them up, and get a vector that points straight 180 degrees opposite the fourth one. So A plus B plus C equals negative D. And we can put that in writing, i.e. we can do this with code. Let me jump to a spider this time. So I've been working with Q vectors anyway. Let's say A plus B plus C, and we get back this vector 1, 1, 1, 0. But that's the same really as going negative D, which is also 1, 1, 1, 0. So that's clearly if we're able to do negative A plus B plus C, that gets us D, and therefore D is not linearly independent. Now that's D, not negative D, right? So that's, in other words, we were able to add A, B, C, and produce, actually in this picture, D is going straight up. But it doesn't really matter which one we call A, B, C, or D. The point being we can create the fourth one using the other three as long as we permit ourselves to do negation. But negation is a kind of rotation in this picture. If you have an x-axis going to the right and you can't reach any points to the left unless you go the other way, well, our solution is scalar multiplication includes basically two operations. One operation is to grow or shrink a vector. So when we're not changing its direction, we multiply by 1/2, it shrinks by 50%. If we want to make it really long, we multiply by 10, it's 10 times longer. And then we can add vectors. And adding vectors is very simple. When you add this plus this, then it's where you would get if you went tip to tail. So this point up here is the vector sum of these two. We also have vector subtraction. So that's all the same with quadrays. It's just the reason we would say they have four basis vectors, quadrays do, is because we don't need negation nor accept negation as a valid way to reach points in space. We can get to any point in space we like just by using positive not whole number, but just positive coordinates and 0. So let's create an XYZ vector, for example, of, say, negative 100 to 45. Just pull that out of a hat randomly. Let's give it a name. It's, some kind of XYZ vector. I'll call it XYZ equals that. Now in quadrays, if I just do XYZ quadrays as a function or method of the vector type, then it doesn't work because it's actually not plural, just quadray. So there is my quadray coordinates, and you'll see one of the coordinates, at least one, is always 0 because we don't need a vector in all 4 quadrants. We can get by with one quadrant at a time. Our point is going to be in one of these directions, one of these 4 directions from the origin, meaning one of the 4 vectors we can consider it dormant in the case of any point. But you'll see that these vectors are all positive, or excuse me, the coordinates are all positive. Now if I want to go back to XYZ, I can do that too. I can just call the convert function and go backwards. So I have bidirectional to and from. There's a little bit of rounding error here. I'm working on making these more consistent with extended precision numbers as well. Right now I'm just using floating point numbers. So it's an interesting approach to linear algebra. What I'm suggesting is we consider this, quote, a wrong approach, and we come from the humanities where we don't know any math really. We're kind of ignorant, let's say, and we come to the mathematicians with our quadray coordinates and just ask some philosophical questions. And from there, we also continue to elaborate our whole number volumes. Remember now, when I say whole number volumes with regard to the Bucky stuff, I'm not saying all polyhedra have whole number volumes. It's just we anchor our core polyhedra differently. Our let's see, what other, I'll wait for another video to review all that. This one, I think we can tie it off right here. Thanks for your patience. We'll talk to you soon.